Yeah, let me change. Basically, apart from documenting a lot of stuff, I'm now negating whatever is passed here. And I just changed my mind. So I want to get rid of D and just pass B here. And then just copy that, whatever we pass. Hopefully it's not that hard to fix the documentation for that. Okay, let's see then. In minus one dimensional hyperplane orthogonal to a given normal vector n, located at signed offset d from the origin in units of normal vectors. That's not even true. Well, never mind that. B equals nothing. I have a minus B here. I want to know what B is. Where does it say? So in Euclidean coordinates, sorry, Euclidean units, that is just the units that you use for, let's say, the coefficients of the normal vector. That offset is equal to B. Is it not true? It's not true. We're not talking about the signed offset of the plane from the origin. The signed offset of the plane from the origin is rho is this, and D is minus B. This clause follows the convention originally set by Ludwig Otto Hesse with respect to the signed distance. The Hesse form of a hyperplane is where n is a unit normal vector. The length of n is 1, indicated by giving n a head, and reads n head dot x is rho. I think that we also can change rho into d. Now I'm getting rid of d first, of course, but then we can maybe rename the rho to d, because I think that is one of the things that is used. Yeah, well, on this Wikipedia page they are using d. They're using vector r instead of x and n0 instead of n, but well, not going to copy it exactly. Yeah, rho is the signed offset of the plane from the origin. Rho is positive if and only if the plane lies in the direction that the normal points to, maybe? Points in. You point into a direction. Or just points to work as well. So we have a normal here, n. I'm just copying basically the image from that Hesse page. Yeah, if anyone wants to look at it, I'll paste it in the chat. However, the signed distance s of a over point A to the plane, that is also a bit... The signed distance SA from the plane to a point A. Is relative to the plane itself and also positive on the side of the plane that n is pointing towards. That's more like also. I'm going to remove also, it's a bit vague. And positive if A is on the side of the plane that n is pointing towards. Let me put the A in here then. Okay. Still no D, right? Let a point A be given by its projection P onto the plane, and it's... And I'm changing this thing a little bit too much. Okay. Let the point A be given by its projection P onto the plane and its assigned distance S from the plane. So A is P plus S times n heads. Then the assigned distance of A to the hyperplane n head dot x minus rho equals 0, that is the hyperplane, is S of A is n head dot A minus rho. And why is that the case? Well, because if we fill in A, we fill in P plus S n head, still minus rho, multiply the n in, distribute n, I guess, so we get n head dot P, still minus rho, plus S n head dot n head, which is S, because, well, P is in the plane, so this is 0. Because, you know, that is the plane, so P in the plane means that this is 0. And n head, this is the length of n squared, this dot product. The n head has a length of 1, so 1 squared is 1, so that is S. Therefore, you see that this definition indeed gives the S as we defined it here. Note that the assigned distance of the origin itself is... No, you just fill it in, origin instead of A. So you get n head dot origin minus rho. And that is, of course, minus rho, because, well, origin is 0, 0, 0. Lots of zeros. Still zeros. And that is the opposite sign of the plane offset, exclamation mark. And I don't do that lightly, exclamation marks. I think it cost me a whole day, that problem. Well, where does that sign come from? I had sign problems all over. Yeah, I mean, like, obvious. The origin is on this side, so the arrow points the other way, and this was positive, so now it's negative. I should add a row here, right? Minus rho. I mean, this distance is exactly the same as that. So, space equals space minus rho. constructor of this class is intended to accept a normal vector n and the dot product of n with some point p in the plane. Yeah, and that is D, but we're going to pass B now, which means that it is negative that, and I should reflect that in the sentence as well. So, and the negative, I guess, the negative of the dot product of n is some point P in the plane. Note that in the literature it is common to write the equation of a hyperplane as n dot x plus b is 0. The hyperplane also stores n and b. Because P is in the plane, we have np plus b equals 0, which follows that b is minus n dot p. If we write the plane equation in Hesse form by dividing by the norm of n, so we had n dot x equals rho. That is the Hesse form. I think I used it already, like here. But now we have n without a head, and here. So now I'm just going to divide this by the norm of n. It's got n divided by the norm of n, which is n hat dot x. Yeah, minus b divided by the norm of x. I'm going to replace this by minus b then. Maybe do it in 2 steps, or maybe even in multiple steps. Let's do it in multiple steps. Can do n dot x plus b divided by n, yeah, equals 0. It is just this divided by that, which then is n divided by n, which is n hat, plus b divided by that. No, okay, let me change that into plane offset multiplied with minus n. Note the point minus b divided by the square of the length of the norm of n times n lies in the hyperplane. See, it gets less and less readable. I added such a nice forms, and then I just changed the variables a few times actually. Now there is nothing left. But yeah, it is how it is. Maybe you can go through row. So to use row first. The point that actually lies in the hyperplane is, I think, row times n. Row times n hat, I mean. Yeah, so we have row is the plane offset, which means that if you multiply row with n hats, you can see that here, more or less. If this n here is a unit normal vector, and rho is the Euclidean distance, then rho times that n hat is the vector from O to the hyperplane. So that point, that point as rho times n hat is the projection of the origin onto the hyperplane. Let's call it that. Yeah. No, I already used P. So. Okay, let's fill this in. So rho is what? Rho in terms of B. Yeah. Rho is minus B divided by that. That is minus B divided by that. Let's not use the dot here. And a square there. Can undo a lot. So you have had the same thing. So this is minus B divided by the norm squared n. What I had was minus B divided by the norm squared n. So yeah, that's correct. Let's do a redo, and then I'll just paste in what I just copied. The perpendicular distance between the origin and the plane is the absolute value of rho, is the absolute value of b, divided by the norm of n, which of course follows immediately from this. Let's continue here. The signed offset of the plane from the origin is, per definition, rho, per definition between quotes, is minus b. Yeah, already had that here. So maybe we should put that before that. Should I put it at the top actually? Oops. The signed distance of the origin from the plane is minus rho. Which is plus b. We don't have a d anymore actually. Create a hyperplane that satisfies n dot x, yeah, plus b now, equals 0, where b is minus np for some p on the plane. And now we're going to just pass b, and then solve that. This d means dimension, so it's not the same thing. I think I got rid of the d. Yep. So a big change here is that now the second argument has a different sign, and the rest did not change. And here we have all the usages of Hyperplane. I just went through this one, so this is this file, I mean. Don't need any other difference. I must negate the second argument again. Yeah, that kind of sucks, but okay. Let's put the dx up front. Yeah, I don't know, man. I think I want to put, let's do minus dy times x1. plus dx times Hi Moses. Yeah, well, that does mean that AI has to understand the code. I use an AI, by the way. I wrote it and then I asked the AI to verify it. And I needed several iterations. And a lot of manual work. You really can't just say, hey, document is ready. Hi, Joker. Yeah, so this is the normal, apparently, because you have to pass the normal. And then, yeah, minus dy is then minus the normal. It's that... Maybe, I mean, if I now look at the documentation, I would say... I could say a normal. I think I do that elsewhere, like normal. Yeah, normal x, normal y. I should probably do that here as well. I mean, just use those variables. The normal of the x coordinate of the normal is dy, obviously. And then here I'm just going to do normal x times x1 plus normal y times y1. That is the dot product between the normal and the point x1, y1, which is in the plane. And then put parentheses around everything and put a minus in front of it. As per the documentation, as it were, minus the dot product of the normal and some point in the plane. And here then I get the same thing. So x, normal y. And then this should be this should be negated again. And although it doesn't make any difference, I'm going to put the normal up front here as well. Is that how I wrote it actually. This, sorry, no, I don't know anymore. This is intersections. Nope, it's not. Let's quickly jump to Hyperplane. We wrote that B. Surely it's somewhere now B is, yeah, here. Minus a row, that's not helping. Yeah, B, yeah, okay. I put normal up front, so it's minus the normal times the point. That's why I want to put it here up front as well. Pattern recognition, easier. I think those are the only hyperplanes that I had in the hyperplane objects in this file. Now see, now they look the same. It's just the negative over normal x times some point x plus and so on, and here the same thing. And then I have another file here. Contains 3 hyperplanes. I'm also going to put a normal up front, so we have to negate it again. And I'm going to put a normal up front. That one is still negated. Yeah, that was commented out, so I guess that escaped my attention. And then after doing all that, everyone realizes that it would be super nice if you could just pass a point. I think I'm going to do that afterwards. Let's see, I've had a few things to test. One of the tests was around here, yeah, this one, for example. This thing has 2 half lines from P1. So I think that's, let me think, was this is a half line? Nope, it's not. This is a half line. I mean, you don't see it here. And this is a half line. This line. And yeah, at some point that was drawn wrong. So this line wasn't even visible at all. But now they look okay. Still drawing it okay. Man, the number of times I change this starts to be ridiculous. I don't even want to look at it anymore. Let's call this correct. That's just a negation again. Almost the same comment. Revert is not the right word. What is the right word? No. Oh, where's my dot? Well, ABI has been broken like totally. Let's call the API breakage. Didn't push cairowindow yet. Okay. Next, I think I want to move everything to math, or not everything, but the hyperplane and the hyperblock. So you have, I have in cairowindow the file inter section points. And I want to move stuff from that to math. However, maybe not everything, I'm not sure. And then in math, probably should separate them, although it almost makes no sense, I think, to only include one of them. But yeah, separate them anyway. And since hyperplane is one word, I should get rid of the capital P here and just call it plane. That is an API breakage, of course, but at least not one where suddenly your program doesn't work anymore, but one where it just doesn't compile, which is a little bit better. It's a rename anyway, because yeah, now we have different namespace, sorry. Just drag it into intersections, why not? But still rename Hyperplane to Hyperplane. Yeah, I think that should already work. Missing header. Huh? Oh, it's missing this vector. Yeah, we need an n-dimensional vector, and I don't really want to call it hypervector, because come on, vector in n dimensions is simply called a vector. Now I already have a vector in math, which is very stupidly two-dimensional. What does this one have? Well, maybe the other way around. What does the other vector have that that we don't have? VI math vector.h. So this is totally two-dimensional, and you can pass it like that. Okay. Yeah. My whole math library is actually two-dimensional. It's using point. What else is it using? Oh yeah, direction. Line piece. Oh, because I want to be able to construct a vector from a line piece. It's just from 2 points. Oh no. Yeah, still. Let's first have a look at points. I'm thinking about making all of math multi-dimensional now. N-dimensional. Well, at least enough to have vector n-dimensional. So that means that point must be... Oh, wait a minute, what am I doing here? Draw point, math point. This must be multi-dimensional. Really? That is defined elsewhere. Probably because of otherwise circular header dependencies. So we make this template, it must become all header, and then if you have circular header dependencies, you have to use dot inline functions, headers, I mean, which I don't like at all. Or I can define everything in one file, I suppose. I mean, theoretically, point needs direction and vector. A vector needs point. Why do I need vector? I want to be able to add a vector to a point. Or subtract one. Also contemplating if I not should just drop all this and start to use eigen. The downside is of course that you always have to link with eigen. But yeah, that is just a tiny little bit of CMake knowledge, I suppose. It shouldn't be that hard. Those are big changes again, right? Am I clean? Math on track contents. Hyperplane.h. Oh, I just created that one. Okay. Can leave it that. That is still not committed. And the other one. Modified content. Same thing. I just moved stuff. So I'm really working on this. As part of the big change, as it were. Okay. think it can do both actually. Oh shit. It's still thinking longer. I get, oh, it's Carlo vibe. Let's think long, and then only 9 seconds. Both fixed size, compile time. Use template parameters for rows and calls, fast, enables loop unrolling and better vectorization. Example, a 5D vector, fixed set compile time. 551. Okay, it's a matrix. It has aliases 2D, 3D, and 4D. Dynamic size, runtime, use okay, let's just try to replace my point with this. And slowly move the icon. Emphasis on slowly. Unfortunately, I mean, it's not deliberate. But, so that means, and I want to put that in math, right? So I'm going to edit math point, and then we just, what do you mean point? We don't have that. Which totally stops everything from compiling. Just case in point. Unknown type name point. However, well, okay, we'll say, well, using points, and then we're going to use this, and then of course it doesn't compile either, because, well, what header do I use for that? I need a header now. Would be nice if I had a project, if I could remember a project that used icon already, and I do, obviously, but yeah, find that back. Find, let's hope that it is an AICXX, always easier. Let's say name CMake lists dot text, execute grab probably icon. I can try that. Yeah, nice. Linux viewer test suite hunter examples. That's AI test suite hunter examples. That's not my code. I'm already using icon in the cairowindow. Oh. In the math test suite even. What? Don't tell me math is already using icon. No, just a test suite is. It's totally linking with icon here as well. Just gradient descent, parabolic scale. GC, parabolic scale, nothing. I can dense. Suppose that's what I need then. Or not. Turn this around. I think I have to look in the Linux Viewer for a definite example that uses it. That's what I want to use. Waarom heb ik opeens zin in een gevulde koek? Probably because I didn't eat enough. I'm feeling this takes too long. I don't want to search gigabytes of binary stuff. Ugh. Just one. Okay, now you done it. I want to see this one and the CX axis now too. Oh, great! Holy, what the? Eigencore. Is it? No, it is no. Well, in case it is then. So, that's what I'm going to include, because it should work. And yeah, also need the CMake stuff. Let's add it immediately. Don't even know which. Tab I was in. I think this one. No, nothing, man. Find. It's gone. I had it in this same project, I think. There we are. Cairowindow has it already. So this now comes a requirement on math as well. It is already included. Oh yeah, of course it is. I'm just kidding. I mean, what the hell? So annoying. Eigen core file not found. Well, now everything needs eigen, but I guess we didn't link with it then, or I mean, I'm so confused. Oh, this is a cairowindow chess. But Hyperplane is the file manager. No, it's a mathematical object. If you have an n-dimensional space, then a subspace of one dimension less, so n minus 1 dimensions, is usually called a plane or a hyperplane, because it's not really plane then, of course. This is the chess object library, but I'm a bit confused. CD cairowindow chess. Yeah, I should link with them. Wait a minute, that is no, huh? What? Yeah, math is its own thing these days. Just link with math. It's relatively new, so before I wrote this, math didn't exist, and now I moved stuff to math, so it has to link with it, which then should drag in eigen, I would think. We still fail on file not found. So trying to compile this in what directory? Could be a problem with math, but I don't even see math mentioned here, to be honest. There's nothing math about it, which it doesn't have to, I suppose. What is the problem then? Oh, I made it private. Yeah, these must be private. This must not be private. Interface. Kind of lame, but now what is more or less the same problem, but that just means that we are not linking with eigen in terms of CMake. This time that happens in math itself. So while compiling, yeah, it's not interface, nonsense. It's just public. The face would be like, I don't need it myself, but stuff that links with me does. Well, let's put this event first, or yeah, let's put it first. Feels like more logical to put the public stuff first. Type def redefinition with different types. I can vector, aka made of double stuff versus math point. Oh, I had a for declaration. Yeah, it wants me to include a whole header. I have to agree with that. This will probably work though, but Yeah, then you're using internal gods, I would almost say, even though it's just a for declaration. Like all the yeah, all the default template stuff. Yeah, maybe not. Shall I try this? I'm going to try this. So that's not how you do it. Cannot have the forward. Sorry, cannot have the default. Yeah, and this is not mine anymore. But can make it 3 functions. Do I still have to define that here then? Well, I probably don't know direction in the header, so okay, let's turn this into a free function, as in the first argument, and is this pointer is now a math point. And they should return at that point plus the direction. And then hopefully we can construct it like that. This is now attempting to change. Yeah, the cairowindow point is math point, which is now eigen point, which probably does not expose access to the coefficients, so let alone call them x and y. I'm too lazy to look up the real documentation. Probably should do that instead of asking it here. Yeah, this would be pretty lame. You can do that. Maybe it's not that lame. Assign to the, use the assignment operator of the base class, right? Like this. But then this is the, yeah, no, I don't like that. Because that looks the most like it. Index based, it's even better maybe. They do have an X and Y though. Yep, can no longer rely on the base class, but well, because it doesn't exist. Or I could have a cairowindow point anyway. And then add and print on to that. I have to actually, or yeah, no, not really. I could define an OStream operator directly. Let's assume that that already exists. Yeah, but then again, well, this was a math point, which is now an eigen thing. It's not even clear what the problem is. So wait a minute, I made a point equal to a vector. Not working because so my vector also is a vector, but yeah, I treat points as vectors as different things. It ain't working. I think I'm gonna quit anyway for today. I still have to do something. And it's also almost 2 AM, so probably should stop streaming. I'll look in this tomorrow, I guess. I'm not convinced that using eigen is the answer here. It makes stuff difficult, very difficult.